So I've been driving around and mapping with Marvin there. Marvin is a Nito Botvac that's got the Raspberry Pi. Look into my LiDAR. It's got the Raspberry Pi. You plug into the USB. You can drive the robot, read the odometry, read the LiDAR scans. And that Mike Ferguson wrote the original Ross Botvac package, and it's the Nito package, and Ralph Ganock has since updated it. And at the SV Ross, we meet the penultimate Wednesdays at the Hacker Dojo. Everybody should come. We're having a great time. Everybody's on the mailing list? Yes, okay. So I've driven around and I've made this map, okay? And now, nothing up my sleeve, I shall save the map. Give me a break. We're having the HBRC challenge next month, and that's going to be phase 2, like Osman mentioned. So everybody is responsible. Everybody is responsible for the meeting next month. You've got 4 weeks. If you're not working on a robot, you're not clear on the concept. Okay, and so you've got 4 weeks to put something together and show up and show it off. And the great thing about it at the Homebrew Club, we're also about second and third chances, so you'll have another opportunity to do it in October. That's when our challenge was. So now I'm going to save this map. The map has been saved, and I'm going to load in the navigation stack. The navigation stack in ROS, Robot Operating System, consists of 2 components, the path planning and the localization. Path planning is called Move Base, and the localization routine is AMCL, Adapted Monte Carlo Localization. So I'm going to kill the G mapping, the grid mapping routine, and I'm going to load in the navigation stack. Ralph Ganock has written these marvelous launch files that load a couple of ROS nodes simultaneously, so it makes it easier, okay? And so now we see the map that I saved, and you can see the boundaries around it. Bear with me. Let me flip this around, move this up. Robot's not quite localized. There. So you see the boundary mark, you see the perimeter barriers around there. You can see the robot, he's a little delocalized because I picked him up and set him down. I'm going to do one thing here. I'm coming up to the top and I'm clicking 2D pose estimate, and I'm going to move him over a bit. Point, press, drag, mouse up. And you can see he's set a little better in that corner.
It's hard to see.
I know. If I try and plug it in here, though, it's going to be a big. It's going to be a big problem.
Can you put it on the table so it shows up the camera?
There we go. How about that? What am I doing?
For 90 degrees.
Yes.
There we go.
Okay. So now I'll come over to the set 2D nav goal point, click, and I'm going to pose him right in front of the podium. So point, press, drag, mouse up, and you see path planning lines going now. The robot's navigating. While the robot's navigating, I'll show off my other robot. Burning Man is August the 26th through September the 3rd, and I don't need this, okay? But their theme this year is iRobot. And I've been 6 times. We went from 95 to 2005. I brought my robot, my Burning Man robot, springy thingy, the goal being to leave the event with a functioning robot. I don't need this, Burning Man, but the theme this year is iRobot, and so I'm obligated. I've got 20th anniversary springy set up and ready to go. But this is a robot that I've got gifted from Wayne. His name is Benson, okay? And I'm working out the Arduino GPS circuit here, and in doing it, I've already blown 3 deadlines. Oh, by the way, the robot set his pose here. Do you see it? You can applaud. Do you see the robot? You see how he's going? Thank you very much. So now I'll send him back to the corner. 2D nav goal. Point, click, point, press. Drag, mouse up, and the robot will navigate back to the corner. So here, I tried to get this ready for Robo Games, the Maker Faire, and the HBRC Challenge. Boom, boom, boom. Okay, Burning Man's coming up, so I really got to get it done. So this is a GPS from SparkFun. This is the SparkFun Redboard. It's an Arduino. And reading the GPS, it's got a lot of great information. But there wasn't a bandwidth to, okay, there probably is, but I couldn't figure it out, parse the data from the GPS and run the motors at the same time. So what I do is I have a Arduino dedicated to the GPS, just reading the data, and it's doing the math. What I learned a couple of years ago with the Robo Magellan contest, which you're just sending a robot to a particular GPS coordinate, is it's basically XY coordinate problem, where if you have a target coordinate and you have where you're located, the actual, I have a GPS on board. If you subtract the target latitude from the actual, you need to go, if the target latitude is higher than the actual, you need to go north. If the target longitude is higher than the actual in the western hemisphere, you need to travel east. And so now you know what direction you need to go in, and the GPS gives you the bearing. And so I'm programming it to follow a 45-degree corridor towards the direction that it goes. In other words, this reads the GPS and subtracts the target latitudes and longitudes to determine what direction I need to go in. And so I go forward, and you get the bearing 0 through 360. 0's north, 180 south, 90's east, 270's west. And so if my target latitude is higher than my actual, and my target longitude is higher than my actual, I need to travel northwest. And so now, you know, the robot knows that it needs to stay in this 45-degree corridor between 0 degree, or I should say 45-degree, let me work it the other way. If I'm tracking north, 315 and 45, if the bearing that I'm traveling is lower than 315 and greater than 180, I need to actuate my left wheel to get back into that 35-degree corridor. If my bearing is greater than 350 or greater than 45 and less than 180, I'll actuate my right wheel to get. So the point being, I know what direction I need to go in, and I can send the robot in that direction. The great thing about it is you can develop this system. It doesn't matter the wheel diameter nor the track width. So you can develop this system on a small robot like this, and it'll work on my large robots also. I've got three or four different bases that I'm going to use it with. So anyways, Burning Man's 26th through the 3rd, and the theme this year is iRobot, and we're going to be out there roboting, and it's going to be so awesome. Thank you very much. See, the Marvin there has gotten back to the corner, right? Right. All right. Thank you. Navigation, Wayne. Navigation, right? All right. By the way, let's see.
Is that the great circle?
Actually, let me do one thing here to prove I've got communications to my secondary board. So I'm going to say 0 and 180, and let me make sure I send it to the right Arduino, and boom. Oh, he's gone the wrong direction. That's okay, you get the point. That's basically the second Arduino listening to the first one. Thank you.
Yay.
Well, I brought this robot last month. His name is Red. And I brought him again because I get, every time, I'm going to attempt to make him a table bot.
Table bot, yes.
Oh, and he just reset. Oh, so now I need a minute. Ralph?
Unfortunately, again, not a fully working robot for me.
Thank
All right,
you.
so I keep bringing it back in little incremental progress on it. So you'll see it's actually powered up, and it has a neato LiDAR on it now that's scanning. I just cannot get the Wi-Fi to work as usual. Can't find my phone. And
Yeah.
I got a connection, but when you run ROS, it says it's trying to find local host instead. There's some weird thing for the naming or something. So
Are you trying to
next
go,
month,
are you trying to go through the Google's?
No, I set my laptop up as an access point. I set this
Okay.
up, and none does the same bug every time it happens. It connects
Yeah.
fine to my home router.
Yeah.
Promise by next month I'll actually have it working. So now you're at home, it will actually do mapping and navigation, same as camps. So it's had some fairly major upgrades recently. The LiDAR is one of them. Put a new power supply board, discovered this great little regulator. It's a buck boost, so it'll take from like 8 to 25 volts in and give you normally 12, but you can actually even program it to a 5 to 24 volts out, so the battery can go above or below it, and it continues to give you power. It also works as an automotive power supply, so it has an output that will control the power switch on the, I have a Jetson TK1 on there, so when you turn this on, it'll actually send a power on message to the Jetson, and when you hit the off button, it doesn't turn off immediately, it sends a shutdown signal and waits for the Jetson to shut down, so it's really nice.
Show me the robot.
So the other enhancements that I've made on it, added a touchscreen, so there's a little TI 4 eval board on there, interfacing stuff, so it's acting as the USB to serial conversion for the LiDAR, and I've got a RoboClaw motor controller. It's also got its own serial link, so now it's a touch panel LCD, so I can start displaying stuff like network config, should be getting done through that.
Is your Pi connected to
There's
it?
no Pi, there's no Raspberry Pi, it's just the Jetson.
I see. But that's a screen for your Jetson.
It's sort of the screen is controlled by the little ARM4, so you sort of pre-program a little GUI with some buttons and stuff on it. So it has an IMU and a real-time clock, so should be a pretty powerful ROS robot. So working at home, but I'll promise by next month I'll get it to actually.
You say it's a touch screen? Is it?
Yeah, so this is a little touch screen, so button there. You can change the backlight brightness, save options, basic interactions with it without having to have a laptop.
That's important.
Which is really good. So. Okay, next time we'll see you driving.